Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam February-March 2023, paper 62. Let's start it. Question 1. Long chain alkane can be broken down into shorter chain alkanes and gaseous alkanes. Vapor of the long chain alkane is passed over a very hot catalyst. The catalyst here is aluminium oxide. And the gases formed are collected over water as shown here in the diagram. So here we have the long chain alkane on a mineral wool is heated and then passed over the very hot catalyst aluminium oxide. It is broken down into shorter chain alkane and the gaseous alkene, and the gaseous alkene are collected over water. Name the item of apparatus labeled A. As it's shown here, A is a trough. The catalyst is small pieces of aluminium oxide. Explain why several small pieces of aluminium oxide will speed up the reaction more than one large piece. Of course, several small pieces of aluminium oxide have larger surface area than the one large piece, so increasing the surface area will increase the rate of reaction. Name the item of apparatus that can be used to heat the long chain alkane and the catalyst. Of course, we can heat using Bunsen burner. Draw two arrows to represent where the apparatus should be heated. Here we will draw two arrows, one arrow below the long chain alkane and the other one below the catalyst aluminium oxide, and the two arrows should be labeled heat. The gas collected is tested using aqueous bromine. Alkene turns aqueous bromine from orange to colors. We know that aqueous bromine is used to test for unsaturation, means to differentiate between alkene and alkane. Alkene only gives a positive result, which is the change in color from orange to colorless. When testing the first few bubbles of the gas formed, aqueous bromine doesn't change in color, means the first few bubbles doesn't give any change in color, no positive results. That's why, because the first few bubbles are bubbles of air that were inside the delivery tube and the test tube. So let's refer back to the figure here. Here we have air inside the test tube and air inside the delivery tube. This air represents the first few bubbles collected. So of course air will not give a positive result with aqueous bromine. That's why the first few bubbles doesn't give any change in color. So your answer will be the first few bubble was air. That air was inside the delivery tube and the test tube. As soon as the experiment is over and the heating is stopped, the delivery tube must be removed from water. Explain what happened if the delivery tube is not removed as soon as the heating is stopped. If you didn't remove the delivery tube as soon as the heating stopped, water will be sucked back into the test tube, and this will cause cracking or breaking of the test tube. Question 2. Student investigate the solubility of ammonium chloride in water at different temperature. The student does 5 experiments using the following instructions. Experiment 1. Fill the burette with distilled water, then run some of the water off the burette so the level of the water is on the burette scale. Use the burette to add 8 centimeter cube of distilled water to 5.5 gram ammonium chloride in a test tube. Then you have to clamp your test tube at an angle. Start heating gently at the bottom of the test tube while steering with the thermometer until the ammonium chloride dissolve in the 8 centimeter cube of water. Then you have to stop heating as all the solid has dissolved. Continuously steer with your thermometer until while the solution cools. Then measure the temperature of the solution as soon as the solution starts to become cloudy and the solid start to crystallize out of the solution. So we will heat until the ammonium chloride dissolve in the 8 centimeter cube of water. Then we will start cooling, measure the temperature at which the ammonium chloride start to crystallize out from the solution. Then we will repeat the experiment. Experiment 2, we will add another 0.5 centimeter cube of distilled water to the same mixture in experiment 1. So we will increase the amount of water from 8 to 8.5 centimeter, and we will repeat all the steps again until measuring the final temperature as soon as the solution becomes cloudy. That means the ammonium chloride start to crystallize out from the solution by cooling. We will record this temperature in experiment 2. Then we will repeat experiment 2 again by adding 0.5 centimeter cube of water. So in experiment 3 we will add another 0.5 centimeter cube of water. Then we will repeat that again in experiment 4, adding 0.5 centimeter cube of water. Finally in experiment 5 we will repeat experiment 2 again. Then we will record the information here, description for all the experiment 1 to 5 as shown here in the table. First we will record the mass of ammonium chloride. The mass of ammonium chloride didn't change, it's 5.25 gram for the 5 experiments, so we will write 5.5 for all the experiments. Then the total volume of water, we start in experiment 1 with 8 centimeter cube of water, and each time we will increase the amount of water by 0.5 centimeter cube. So here we will have in experiment 2 8.5, then experiment 3 9 centimeter cube, experiment 4 9.5 centimeter cube, finally in experiment 5 10 centimeter cube. Then using the thermometer diagram we will record the temperature when the solids start to form by cooling. For the first experiment it's 78.5 degrees Celsius. A second experiment it's 67 degrees. Third experiment it's 60. The fourth experiment 53.5, and finally experiment 5 it's 49 degrees Celsius. Complete a suitable scale on the y-axis and plot your results from experiment 1 to 5 on figure 2.2. Draw a line of best fit through your results. So first we will use a suitable scale for the y-axis. Here the scale starts from 30, so we will continue 40, 50, 60, 70 until 80. The highest temperature here is 78.5, so your scale will be until 80. Then we will draw a line of best fit through your points. Line of best fit here is not a straight line. To determine if the line of best fit is a straight line or a curve, we have to refer back to the results. For the line of best fit to be a straight line, we must have a linear relationship. Linear relationship means that when one variable increase or change by a constant rate, the other variable should change with the constant rate. So here we have the volume of water change by a constant rate, which is 0.5 each time, but the temperature isn't changing by a constant rate. As we can see, each change is different. So the changing in temperature is not by a constant rate, so this is not a linear relationship. That means we should draw a curve, not a straight line. So we will draw a curve between the points here, and the line of best fit will be a curve, not a straight line, because we don't have a linear relationship. So here we plot all the points, and then we draw the curve of best fit. Then deduce the temperature when the solids start form when the total volume of water is 10.5 centimeter cube of water. So we will go back to our graph. Here we have 8.5 centimeter cube of water. We will go up till meeting the curve. At this point the temperature is 46. So we have to show your work on the graph as it is drawn here with the blue lines. The final temperature when the solids start to form is 46 degrees Celsius. Solubility in gram per 100 centimeter cube of water is calculating using the equation shown. Solubility equal to the mass of the solid dissolved times 100 divided by the volume of water used. Use this equation to calculate the solubility of ammonium chloride in experiment 1. So in experiment 1, the mass of the solid is 5.25 grams times 100, and the volume of water used is 8. So we will use this calculation to find the solubility of ammonium chloride in experiment 1. It will be 65.6 gram per 100 centimeter cube of water. Describe how the solubility of ammonium chloride change as the temperature change. Solubility increasing by increasing temperature. In this experiment, the volume of water was measured using a pipette. State the advantage of using a pipette rather than measuring cylinder to measure the volume of water. Of course, we know that pipette is more accurate than the measuring cylinder, and this is the advantage of the pipette. State the advantage of using a pipette rather than a volumetric pipette to measure the volume of water. Pipette can measure variable volumes, but the volumetric pipette can measure only one fixed volume. The total volume of 2 centimeter cube of water is added to the original 8 centimeter cube of water. So each time we add 0.5 centimeter cube, so the total volume added is 2 centimeter cube in the 4 experiments after experiment 1. Explain the disadvantage of adding 2 centimeter cube of water in 1 centimeter cube portion rather than 0.5 centimeter cube portion. So he want to know the disadvantage if we add this 2 centimeter cube in 2 portions, each one is 1 centimeter cube, and instead of adding 4 portions, each one is 0.5 centimeter cube. So if we add it only in 2 portions, we will have only 2 experiments. Less data will be obtained, so we will have fewer points to plot the graph. That means the graph will be less accurate. Suggest why it is not possible to use 6 centimeter cube of water instead of 8 centimeter cube of water in experiment 1. As we can see, the solid didn't dissolve in the 8 centimeter cube of water except by heating, so the 6 centimeter will not be enough to dissolve ammonium chloride. Question 3. Student test two solutions, solution C and solution D. Test first on solution C. Solution C is aqueous calcium nitrate. So it is calcium nitrate. Solution C. Complete the experiment to write the expected observations. The student divides solution C into 3 portions. The student carries out the flame test on the first portion of solution C. As we know, calcium ions gives orange-red color on the flame. So the observation is orange-red color. This is the flame color of calcium ions. To the second portion of solution C, the student add aqueous sodium hydroxide dropwise until it is in excess. So adding dropwise sodium hydroxide, white precipitated form. This white precipitate, of course, is calcium hydroxide, and the observation in excess, the precipitate doesn't dissolve in excess sodium hydroxide. To the product from B, the student add a piece of aluminum foil and warm the mixture gently, and a gas is produced is tested. Adding aluminum foil to the test and warm the mixture. This is the test for nitrate ions. So the positive test for nitrate ion is producing ammonia gas, and the observation will be the gas will change damp bread litmus paper into blue. To the third portion of solution C, the student add about 1 centimeter depth of dilute nitric acid, followed by a few drops of silver nitrate. Silver nitrate is the reagent used to test for halide ions. Here we have solution C is calcium nitrate, so we don't have halide ions, so the observation will be no change. Then test on solution D. The table 3.1 show the test that the student observation for solution D. The student divide solution D into 4 portions. Use a glass rod to transfer 1 drop of the first portion of solution D onto a piece of universal indicator paper. The universal indicator paper turns red. That means solution D is acid, because acid give a red color with universal indicator. Then test 2. To the second portion of solution D, add sodium carbonate and test for any gas produced. As the solution D is acid, so it will react with sodium carbonate to produce carbon dioxide gas. The solid sodium carbonate disappears and there is effervescence. Of course, this effervescence will be for the production of carbon dioxide gas. This gas turns lime water milky, so this is the positive result for carbon dioxide gas. The third portion of solution D, we will add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. No change, that means no halide ions. To the fourth portion of solution D, add about 1 centimeter cube of dilute nitric acid followed by a few drops of barium nitrate. Barium nitrate is used to test for sulfate ions, so formation of white precipitate indicates that we have sulfate because sulfate form a white precipitate with barium sulfate. That indicates that we have sulfate ions. So here solution D is an acid, and this acid have sulfate, so this acid is sulfuric acid. Deduce the pH of solution. Of course, sulfuric acid is a strong acid, so we can write pH 1. Identify the gas made when the sodium carbonate is added to solution D. Here in test 2, the gas is carbon dioxide because it turns lime water milky. Identify the 2 ions present in solution D. As we said, it's an acid and contains sulfate ions, so it's sulfuric acid. We have the hydrogen ions and the sulfate ions, and solution D is sulfuric acid. Question 4. Cadmium, cobalt, and vanadium are all metals. So we have 3 metals, cadmium, cobalt, and vanadium. They react with dilute hydrochloric acid to form hydrogen gas. So all the metals can react with dilute hydrochloric acid. Plan an investigation to find the order of reactivity of these 3 metals. Your plan must make it clear how your investigation will be fair test and how you will use your result to place metal in order of reactivity. So you have to show your experiment is a fair test and how to show the order of reactivity of these metals. You're provided with powdered sample of each metal, dilute hydrochloric acid, and all common laboratory apparatus. So as we said before, the condition of a fair test that you have to keep all the variable constant except the variable which is tested, which is the type of the metal. So we will only change the type of the metal in each experiment, and we have to keep all the other variable constant. As we will write here in the experiment, we will write all the variables should be kept constant for the fair test. So first, we will use the measuring cylinder to measure 20 centimeter cube of hydrochloric acid of a known concentration, then put it in a beaker. Measure the temperature of the acid by a thermometer. Add a known mass of cadmium to the acid. Then measure the maximum temperature reached and record the increase in temperature. Increase in temperature here will be the difference between the final reading minus the initial reading. The final temperature minus the initial temperature. Then we will repeat experiment. Here is the condition for the fair test. We will repeat experiment with the other metal, which is cobalt, using cobalt and vanadium, of course, for the 2 metals. We will repeat the experiment using the same mass of the metal, the same volume, and the same concentration of the acid. Each time we will record the increase in temperature, which is the difference between the final reading or the final temperature minus the initial temperature. The metal that causes the greatest change in temperature is the most reactive metal, and the metal that causes the least temperature change is the least reactive metal. We have to write these 2 experiments to order the metal according to their reactivity, because here the examiner asked me to make it clear how your investigation will use the result to place the metal in order of reactivity. So the metal that gives the highest or the greatest change in temperature is the most reactive, and the metal which gives the least change in temperature is the least reactive. Of course, the metal that will give intermediate change in temperature will be in the middle. That's how we can order the metals according to their reactivity. Here we come to the end of our exam. Thank you for watching. Wish you all best of luck.